Yeah, good. I'm going to pass the sign-in sheet around now. Just get you all started. Let's see. We are recording. I wanted to show y'all something just to kind of get our brains going again a little bit. This has nothing to do with what we did last time, what we're going to do today. But everyone has been kind of watching what's been going on in the news with that airplane that's missing, right? And I don't know if anyone saw this, but they said that, like, if that's the Earth, right? Whoa. If that's the Earth, that the plane like took off, it went north kind of, and then all of a sudden it lost contact, turned left, and then they think it's somewhere up here or somewhere down here. Have y'all seen that on the news? It's like this arc that goes up or an arc that goes down. Did anyone see why that is that way? Like how they know that? Did anyone see that? Because it seems weird that they would know that it turned and then they know it goes on these two arcs, but like where does that come from, right? Like why don't they know left or right? That make sense? So I'm going to try and explain it to you because it actually has to do with math. It's beyond the scope of this class, but it is mathematical. So let me show you. I prepared this yesterday for my calculus class so they could see it. First of all, let's just imagine that's the Earth, okay? Y'all see the Earth? The plane takes off at some point, has a certain amount of gas, so it can go in any direction a certain distance, and then it runs out of fuel and has to land or crash, right? So let's just say that that yellow point in the center, can y'all see that okay, is where it took off from, and it has this blue circle that it could go anywhere on that circle, right? Now I'm going to move this around so you can see, like, that is the Earth. It's round, right? See it? Okay. So keep that in mind. That's the plane can only fly in that blue circle, and then it runs out of gas. Now, somewhere out in space, there was a satellite. Here's the satellite. Okay, y'all know what a satellite is, right? It's up out in space. And it can see the Earth. Now, do you agree that depending on the distance the satellite is, watch, I'm going to move the distance. If the satellite's really, really far away from the Earth, then it can see all the way up to this point, but it can't see past that point because once you go past that point, the curvature of the Earth basically the Earth would get in its way. Like if I'm right here on this side over here, gosh, I'm shaking. If I'm right here, then no signal I send can get to that satellite because the Earth's in the way, right? So, but the further away the satellite is, the more of the Earth it can see. The closer it is, notice that window of what it can see gets smaller. Y'all agree? Okay. So let me back this up a little bit. And again, I'll turn this so you can see that is three-dimensional, right? That satellite sitting there. So the satellite was sitting there like this, all right? And the plane the engine started to try and communicate with the satellite. So it's basically like sending what you would call in computer terms like a ping. It's just a, hello, is anybody there? And then it gets an answer or it doesn't, okay? So it sent a ping, and this satellite picked it up. Now, that ping came from, what happens is that the satellite gets the ping, and the satellite can measure how long it took to get the ping, okay? So it can measure the distance to whatever sent it. So it knows how far away the engine was. Does that make sense? So it knows how far away the engine was. But because this is three-dimensional, you see that green circle on the Earth? Any point on that green circle, see I'm moving this around, any point on that green circle is the same distance away. Okay, anything on that green circle. So that plane could be anywhere on that green circle then, right? Y'all still following me? Now bring back the range of the plane. If you bring back the range of the plane, we know the plane could only be in here, but it has to also live on this green circle. They know it went north and turned left, and then they lost it. So either it turned up or it turned down, but it's somewhere on that green circle. Does that make sense? That's basically what's happening. So in my calculus class, we're actually going to find the equation of that circle because we can. And so that's how now, the military has computers that'll do all the calculations for them, but the idea is the same as something you would do in a more advanced math class. So that's how they know it's on one of those arcs. Because when I first heard that, I was like, why is it that they know it either turned left or right? They should know if it's left or right, right? But it's because of this, that they don't know which way. They just know it lives somewhere in that green circle. Now, it's also not very accurate. When it says that it's on that green circle, that's when it pinged. It could have turned after that. So that's why it's not just this very narrow line. It's actually, it could deviate a couple of 100 miles each way because it turned. It could have turned again. All right, anyway, that's just math connected to like real world stuff, I guess. That was fun. I was all excited yesterday. I was telling my wife, I have a math problem that I'm going to be able to show my students. They might actually pay attention. Not you, my calculus class. Okay, but for us, we get back to the good stuff, right? We finished up, we were solving systems of linear equations in 2 variables. This was back chapter 4.2 is what we stopped with. So why don't we do a problem? Does anyone have any questions? I gave you homework, right? Anyone have questions over the homework? 33. Okay. Was that the one I said? Yeah, it had fractions in it. This is number 33. We have y equals -1/2 x minus 4, y equals 4x minus 13. And this is a system of equations, so I put that brace out to the side. The book doesn't put the brace, they just tell you solve this system. Now, what was the process that we learned? What are the 2 processes that we have learned to solve something like this? What's that? Okay, yeah, so you're trying to solve for one of the variables, choose the easier one. That's the method of substitution, so that's going to be an algebraic process, right? The first section we did in this chapter is we graphed them, right? We graphed the 2 lines, and we tried to find where they hit, but we learned that that really isn't that accurate. It's better to have a way of getting those numbers precisely. So substitution is what we learned the last class that we were together, and the method was to look at the 2 equations, right? Solve for either one of the variables, x or y, and you get to choose. Well, what do you notice about this? Both equations, right, are already solved for y, right? So there is really not an easier one. They're both already solved for y. So my first step, though, is to choose, I'm just going to choose equation 1. Which one is that one? The top one, right? That's what I'm going to call equation 1. And I'm going to solve for y. But I'm going to put a check mark because that's already done, isn't it? I mean, I don't have to do any work. But that's technically what I would have done. So I'm going to put y equals -1/2 x minus 4. Now, what are you supposed to do with that? Substitute that into the other equation, right? So now what I'm going to do is I'm going to substitute y equals -1/2 x minus 4 into equation 2. Now, equation 2, let me write down what equation 2 is. Equation 2 is y equals 4x minus 13. And I'm going to replace the what with what here? What am I replacing? The y with this thing, -1/2 x minus 4. Right? That's what I'm going to replace. So rewrite this now. Replacing this left side with negative 1/2 x minus 4. The right side does not change, correct? Aren't you glad we're back? Isn't this better than spring break? Everyone understand that? Anyone have questions? Now what? What do you do with that? Yeah, solve for x, right? This is a linear equation in one variable. We actually have fractions too, don't we? So what was the method that we used whenever we solve fractions in a linear equation? Didn't we clear them? How do you clear a fraction? Find a common denominator. Okay, so we're actually going back to stuff we did a while back and having to use that again just to solve this. So I'm going to find an LCD. My LCD in this case is what? 2. The only denominator you have is 2, right? So that's your LCD. And what do you do with that LCD? Multiply everything by it, right? Both sides of the equation. So I'm going to put a 2 on the left. Remember, I'm going to have to distribute that through. So I put parentheses. On the right, I put a 2 with the parentheses. So I'm trying to solve this right now. Distribute the 2 through. What do you get when you distribute 2 through the first set of parentheses there? Here you get, okay, on the top you would have negative 2x over 2 though, right? So they would cancel and you just get 2 times negative 1 over 2. X is going to be negative 2 over 2x, which is negative 1x. Right? So we get that first multiplication is negative x or negative 1x, however you want to put it. What's the second distribution? Negative 8, right? Now equals the other side, 8x minus, I know it's been, you had a long break. I'm just trying to get you all to get your brains going again here. Yes? Questions? Now that we have no fractions, let's get all our x's on one side. Let's get all our non-x's or numbers to the other side. I'm going to choose to add x to both sides. Add 1x, right? I'll put 1 in front of it, because that will cancel out the negative x on the left side. What I'll be left with at this point is negative 8 on the left, on the right 9x minus 26. Now I will add 26 to both sides. That'll get my 26's to cancel on the right. I still have 9x over there. And on the left side, what is that? 18. And finally, divide both sides by 9, and you get x is what? 2. Good. I'll put it right here. X is 2. Okay. What do you do with that? Substitute that back into, way back in that first step. Remember we had the y solved for up there, didn't we? Right up there? Or wait, actually, a little bit further. But remember I told you could plug it into any equation, couldn't you? Anyone. But what I've been doing in class, I'd always been plugging it into that one that we solved for in the very beginning. So I'll do that. I guess I'll do it to the left here, if that's okay with you. I'll plug in here to get y. Y equals negative 1/2 x minus 4. I'm replacing x with 2. So what is negative 1/2 times 2? Negative 1, we did that a little while ago, right? Negative 1, and then take away 4. It's negative 1 minus 4. Negative 5. Is that all right? So your answer, written as an ordered pair, the answer, put it right here, is the point 2, negative 5. Okay. That's what we did last class. Do y'all remember all that? Hopefully you did your homework. Hopefully by the end of the week you'll be back in school mode, right? So today what we're going to do is we're going to learn our last method for solving systems of equations. And this is, in the book it's called the addition method. But it's actually called something else in college algebra, so I'm going to name it both. I'm going to show you both names. That way, when you get to college algebra, if you're going to do college algebra, you'll know what the hell they're talking about. All right? Okay, so today, 4.3, solving systems of linear equations I'm going to put here 2 variables by the addition method. Now the other name that you'll see in other books is called elimination. So instead of calling it the addition method, they call it the elimination method. So if you hear me say we're going to use elimination, that's this. If you hear me say we're going to use substitution, that's what we just did a little while ago. And if you hear me say we're going to solve it by graphing, then that's what we did a while ago. That's when we just graphed them, right? So we're going to have 3 methods total. Okay, so let's see how this works. All right, I'm going to start off with an example. X minus y equals 5. X plus y equals 17. All right, let's talk about the different things that we could do here. We could try and graph these 2 lines, right? We could do what we did last class. We could try and solve one of these equations for either one of the variables, right? If we did that, that would be what method? Substitution, right? If I use substitution on this, I would have to choose which equation and which variable. So anyone, if we did substitution, which one of those would you choose? What would you choose? Second equation for what? What would you solve it for? For y? Okay, that would be perfectly fine, right? You could also do the second equation for x, or the first equation for x, or the first equation for y. All of them are pretty easy. None of them have numbers in front of them other than 1 or negative 1. So substitution wouldn't be so bad here, would it? However, this new method, this elimination or addition method, works like this. Look at your 2 equations. The first thing you do is you make sure you have the x's lined up, the y's lined up, and the numbers on the other side of the equation. So what you want, this will always be the case for this elimination method, is to reorganize everything first. It's like you have a column for x's, a column for y's, and a column for numbers on the other side of the equation. All right? So we have that already. Now I'd like for you to look at what would happen if you add down. This is why it's called the addition method. What would happen if you add these 2 equations straight down? What's x plus x? 2x, right? What's negative y plus y? They cancel, don't they? And you would have nothing. And then what's 5 plus 17? 22. So notice that when we add straight down right now, you actually get your y to go away, don't you? And your x stays. So I'm actually going to do that addition right now. I'm going to take these x's, I'm going to add straight down. I'll even put a line under this so it kind of acts like we're adding these two rows together. X plus x is, you said it was 2x, right? And then when I do y, negative y plus y, you said that gives me nothing, right? And then the other side, you add straight down, and you said that that gave me 22, right? Well, look at that. Look at this line that we have here. 2x, this 0 is really not here, right? So that just means 2x is 22. Isn't that an equation that only has one variable in it now? So x is what? How can you get x here? Divide by 2. So x is what? 11. So I know what x is, but what do I still need to figure out? What y is. So what we're going to do is we're going to take this x and we're going to plug it into either one of these equations, either equation 1 or equation 2. It's our choice. I'm going to choose just to grab equation 1. I'm just going to write it down. X minus y equals 5. I'm going to replace x with what? 11. 11 minus y equals 5. Let's get y by itself here. Subtract 11 on both sides of this equation, right? Subtract 11, subtract 11. You get negative y equals negative 6. And how do you change the negative in front of a y on one side here? Multiply or divide both sides by negative 1, which switches the signs on both sides. So this really turns into a y equals what? 6. You got it. That's it. So you'd write your answers in ordered pair, though. Remember, all our answers need to look like x then y. So 11, 6. What do y'all think of that method? That's pretty nice, right? What's great about it is that when you add down, immediately you've removed one of the variables. But the key to this problem working was the way I wrote it. I mean, I made it so that as soon as we did this, the y's canceled, right? It won't always work that way. But do you get the idea, at least? Questions on the idea, the concept? Okay, let's try one that's a little more challenging. How about 3x equals 17 minus 5y and 2x plus 6 equals y. Now, if you were asked to solve this, and you were given the freedom to solve it however you want, do you think that you would do the elimination like we just did, or do you think we'd do substitution like we did last class? Substitution, why? It's not lined up, and your second equation is already solved for y, isn't it? Isn't that solved for y already? So you could just take that and plug it in for y, and you'd be on your way, wouldn't you? So the preferred method here would probably be substitution. But I'm going to force us to use elimination here so you can see how it works. All right? So the first step of elimination is to rewrite everything with all your x's on one side, x's and y's on one side, and all your numbers on the other. So let's see here. On the first equation, I have a 3x. That negative 5y on the right, wouldn't that need to come to the left over here? Yes? So it would become a what on the left side? Would it still be negative 5y? It would become positive, right? Because we're moving it to the other side of the equation. So plus 5y. And then I keep my equal sign. And then what about the 17? Does it change at all? No. It's still on the right side. I didn't move it. So it doesn't change signs. What about the equation on the bottom? What would this become? 2x minus y equals, now you need the number on the other side. So the 6 was on the left, it needs to move to the right, so it becomes a negative 6. You all agree? Okay. Now, is everything lined up? X's together, Y's together, numbers on the other side. What would happen if you add straight down now? Just try and add down. What would happen? 3x plus 2x is 5x, okay? What's 5y take away y? 4y. And then you put the 17 take away 6, you get 11. So don't write this down, all right? But this is what I would get. 5x plus 4y equals 11. That's what I would have if I added those down. Did the y go away? No. Did the x go away? No. Neither one of them went away, which means this did not help. It basically doesn't work. The other one worked because the y went away, didn't it? This one doesn't. So what we have to do is we have to force it to happen. Watch what I'm going to do. Let's try and focus on the y's. Right now, I take 5y and I subtract y and I got 4y. How could I make 5y and this one go away? What would this one on the bottom, negative y, what would it be, how do I say this? What would I really like it to be? A negative 5y, right? Wouldn't I really like this one on the bottom to be a negative 5y instead? Because then when I add straight down, the 5y minus 5y would go away. So I'm going to force it to be a negative 5y. And the way I'm going to do it is to multiply the entire equation by 5. So on the outside of this, I'm going to put a 5 with a circle to let everyone know I'm about to multiply through this entire equation by 5. And I have to do the entire equation because the only way to maintain equality, to maintain the integrity of an equation, is to multiply both sides by that. So let's do this. I'm going to start a new line, a new system over here. My first equation I didn't even touch. I'm just leaving it alone. My second equation, go ahead and distribute through. What would you get? What's 5 times 2x? 10x. Minus 5y, that's what I wanted, equals negative 30. Now what would happen if we add straight down? The y's will cancel, which is what I want, right? So let's go ahead and add down now. What's 3x plus 10x? 13x. The y's, when I add down, that's 0. Equals over here. Is that negative 13? 17 take away 30 is negative 13. And then I have 13x equals negative 13. Divide both sides by 13. And you get x is what? Negative 1. Now we get to plug that answer into any equation that we have in this problem, any of them. That had, well, they have to have x and y in them, but which one do you want? It doesn't really matter. Let me just grab one. I'm just going to grab this one right here. There. I'm just going to grab it. There it is. You may not have picked that one. That's the one I'm picking. So, and I'm going to take that and I'm going to replace x with what? Negative 1. So I'm going to go 3 times negative 1 plus 5y equals 17. So order of operations here, we're going to go 3 times negative 1 first, which is negative 3, plus 5y equals 17. You can solve that for y now, can't you? What would you do first? Add 3 to both sides. So you get 5y is 20. I'm not going to show that step. Then you would do what? Divide by 5 and you would get y is what? 4. So we know the x, we know the y. So our final answer would be -1, 4. I think another one is in order. Okay, on this one, by the way, this is going to be my last example, and then I'm going to let you work on some, because I think that's the only way to get everyone kind of going today is to let you start practicing, all right? Help wake you up a little bit. First thing you'll notice, hopefully, is that I'm using n and m instead of x and y, just to get you used to the idea of using different variables, okay? So I want us to do this by elimination. I'm asking you to do that on the test. I would tell you use elimination or use substitution, or I would tell you use any method. But if I tell you use elimination, that's what I want to see, all right? So in this one, use elimination. What do we have to do first for elimination? We got x and y's on one side, numbers on the other. Here we don't have x and y, we have n and m. So let's just get our m's and n's on one side, our numbers on the other, rewrite the system. And since m comes before n in the alphabet, right, I'll put my m's first, then my n's, and then equals, and then the numbers. So tell me about this first equation. How does that change if I get the m and n's on the same side? Move the -5 to this side, m, so it becomes a positive 5m? Okay, so I'll have positive 5m plus 8n, right? And then equals 4. Okay. Oh, I like the second equation. It's ready to go, isn't it? It already has the m and n. I had this wonderful, wonderful professor in graduate school. I won't mention him. I won't tell you his name because I'm about to criticize him a little bit. He gave the best notes I ever was given as a student. He was just awesome. But he would go up there and he would talk while he wrote, and he had a strong accent, and he would say, for m and n, he would say yen and yen. And so they sounded exactly the same to me. So if he would say it, you couldn't tell what he was talking about. But if he wrote, you would have to ask him, write it down, because I can't tell, you know, like. So every time I use m and n, I try and really stress m versus n, you know. Good old. All right, what now? Check what happens if you add them down right now. Yeah, see, if we add right now 5m with 7m, right, that's 12m. If we do 8n and 6n, we get 14n, and none of those go away, right? Now, in the last problem, we noticed, right, in the last problem, we kind of said, hey, look, check this out. That 5y, if I could get this to be a negative 5y, it would cancel, wouldn't it? But on the problem we have now, there's no obvious cancellation, is there? I mean, it's not like I can just make this 7m a negative 5m so it would cancel here. Do y'all understand the problem here, the issue that we've run into? Well, what you can do, though, is you can come up with a common multiple of both. So, for example, what is a number that is a multiple of both 5 and 7? What's a number that's a multiple of both? Well, easy way to find multiples of two numbers is multiply them together. What's 5 times 7? 35. So there is a way to turn 5 into 35, right? There's a way to turn 7 into 35. But we need them to be opposite in sign, don't we? So when we add them, they cancel. So let me try and get my 5m here on the top left to become a 35m. So what would I have to multiply by? 7. So I'm going to put a 7 and circle it on the outside. Now, the 7m on the bottom, I want that to become not a 35m, but a what? Negative 35m. So I have to multiply this by what? Negative 5 on the outside. Y'all see that? We're just being clever. That's all we're doing. And now we're going to distribute. Make sure you pass those numbers through. They have to go through both sides of the equation. And what you're going to do is now rewrite the entire system. I should get 7 times 5m is 35m, plus 8 times 7 is 56, n equals 4, 28, right? 7 times 4. That's where I see the biggest mistakes on these problems. People will come up with the numbers, they'll forget to distribute all the way through or something like that. So just be careful on that. Now passing a negative 5 through, negative 35m, plus or minus here? Is it minus, right? Minus 30n equals negative 5 times negative 10 is positive 50. See, wasn't that clever? I did that, and now when I add down, I should get the m's to cancel. Now, before I add down, let me ask you something. I chose to do the 5 and the 7 on the m's, right? I could have done the 8 and the 6 on the n's. But then I would have had to have multiplied the top one by what? What's a common multiple of 8 and 6? Well, 8 times 6 is what? 48? Right? I could have used that, 48. So I could have multiplied the top here by 6 to get 48n, and the bottom one here by negative 8. Right? So you're always using the other one's number, just opposite sign. Does that make sense? Okay, just showing you, you could have done it either way. I chose m. Why? Well, because m's to the left of n. I don't know, that's what I chose, right? But you're free to do either one. So now add down. The m's are gone, right? How many n's do we have? 26. And over here, 78. I sure do hope 26 goes into 78. 3 times. Divide both sides by 26, n is 3. Y'all notice I'm doing this intentionally. I'm starting to show less of the work, like on this to here. I'm not going to continue to show, you know, okay, take that, divide by 20. I'm starting to trim that stuff out. Okay. Now what? Plug it into any one you want, right? You mean this one right here? Or did you mean, yeah, you want to go in there? Right there? Is that okay? I'll do that. So I'm going to write down 7m plus 6 times what? 3 equals negative 10. That's 7m plus 18 equals negative 10. What will I do now? Subtract 18 on both sides. That'll give me a negative 28. And then I will divide both sides by 7. So m is what? Negative 4. Okay. I think that's good enough to get us going today. We'll do more. Yes. Great question. For this one, just do alphabetical order. So just do m would go first and 4. Yes. Any equation that has both m and n in it. What you couldn't do is plug n back into this equation right there. That's the only equation we have on the page that has just n in it. And if you plug 3 into that, it's going to say 78 equals 78, and that's it. You have to have the m in there also so you can solve for the m. So any of them would work. And they all give you the same answer. All right. What I would like you to do, hopefully, does every table at least have a book? Yes? Anyone not? Okay. I would like for you to do some problems out of here, out of the back of this section. And we'll just work until you finish these. Then you can go. But I'm going to give you probably enough that you won't have time. You'll run out of time first. Let's do page 301. 10. Through 20 even. And then 44. Yeah, that's good. What I'm doing is I'm very carefully avoiding fractions right now and making sure your answers all come out to be nice numbers. Let's get this method down. Next class, what we'll do is we'll talk about, well, what if there are fractions? What if there are decimals as far as your answers are concerned? Okay, so that's your in-class work. And then for homework, you should do problems 11 through 21 odd. And then 43. Yes, sorry, that's the same page. Yep. Anyone else need to sign in? The in-class work that you're going to do right now, I'm just going to give you like a what do you call it, a participation sort of quiz grade for it. Everyone have that written down because I want to turn this off. You sign in? Right there. All right, so you got, what, half an hour to try and tackle about 10 problems or so? No, 5 problems?